The purpose of a transmission is straightforward. It makes sure that the right amount of power goes from the engine to the wheels to drive at a desired speed. But what does that look like in a fully automatic Allison transmission? This video will demonstrate how the internal components of a 3000 series transmission work while shifting through each range. In each range, different clutches, numbered C1 through C5, are applied. These affect the planetary gears, which are numbered P1 through P3. The planetary gears include the sun gear, the carrier, which contains the pinion gears, and the ring gear. One of these gears is driven by the main shaft. One is splined to the driven gear, and the last is held. The different combinations of gears that are driven, splined, and held create different levels of torque multiplication or reduction. In neutral, rotational power from the torque converter is not transmitted beyond the rotating clutch module and the P1 planetary sun gear. C1 and C2 clutches are released. The C5 stationary clutch is applied, but no output movement is generated because torque is not transmitted to the planetary gears. Consequently, torque is not produced at the transmission output. The application of C5 clutch during neutral operation ensures that one of the required two clutches is already engaged if any other range position is selected. Clutches C1 and C5 are applied in the first range. In normal operation, calibration determines the point when the torque converter clutch, or TCC, is applied. The TCC transfers input torque directly to the gear train. Torque from the converter rotates the turbine shaft and the rotating clutch assembly, which contains the C1 clutch. When the C1 clutch is engaged, the turbine shaft and the main shaft are mechanically locked together. The two shafts then rotate as a unit at the same speed in the same direction. Torque is transmitted through the main shaft to the P3 sun gear, which is splined to the main shaft. The P3 sun gear rotates inside the P3 carrier. Applying the stationary clutch C5 prevents the P3 ring gear from rotating around the outside of the P3 carrier. Torque is then directed through the P3 carrier assembly as it rotates due to the torque input from the P3 sun gear. The P3 carrier is splined to the output shaft and directs torque to the transmission output shaft. Clutches C1 and C4 are applied in the second range. The P2 planetary assembly provides first-stage gearing in second range. Torque is transmitted through the main shaft to the P2 sun gear. The P2 sun gear is splined to the main shaft and rotates inside the P2 carrier. Applying stationary clutch C4 prevents the P2 ring gear from rotating around outside of the P2 carrier. The torque path is then directed through the P2 carrier assembly as it rotates due to the torque input from the P2 sun gear. The P2 carrier provides the first stage output in second range in a 3000 series transmission. Clutches C1 and C3 are applied in third range. The P1 sun gear transmits the torque produced at the clutch to the P1 carrier. Clutch C3 is a stationary clutch that, when applied, prevents the rotation of the P1 ring gear. With the P1 ring gear held and the P1 sun gear providing first-stage torque input, the P1 carrier is the first-stage output member in the third range. Clutches C1 and C2 are applied in fourth range. The C1 clutch drive hub is splined to the main shaft, and the C2 clutch drive hub is splined to the P3 ring gear to rotate at turbine speed. Because the C3, C4, and C5 stationary clutches are all disengaged, the remaining pinion gears and ring gears rotate at the same speed and in the same direction as the turbine shaft. The P3 carrier provides output torque to the transmission output shaft. Overdrive occurs when the transmission is in fifth range and sixth range. This means that the speed from the transmission at the output shaft is greater than the turbine shaft speed. When overdrive occurs, an increase in fuel economy is achieved, but no mechanical torque advantage is available from the transmission. Clutches C2 and C3 are applied in fifth range. The application of C2 locks the turbine shaft and the P2 carrier together, causing them to rotate as a unit at the same speed in the same direction. The P1 planetary assembly provides first-stage gearing in the 5th range. Input to this stage is through the P1 sun gear. The P1 sun gear is part of the rotating clutch and rotates at turbine speed. When clutch C3 is engaged, the P1 ring gear is anchored, preventing it from rotating. The P1 sun gear rotating inside the P1 carrier transmits torque to the P1 carrier, which provides the output for the first stage. The P2 planetary pinion gears are the second stage of the 5th range operation. The P2 carrier is splined to the C2 drive hub and provides one of the 2 inputs to the P2 pinion gears. The other input is the P2 ring gear that is splined to and rotates with the P2 carrier. The P2 ring gear rotates around the outside of the P2 carrier assembly at a slower rate than the rotation of the carrier. This causes the P2 ring gear action to resemble that of a held member. Torque is then transmitted through the P2 carrier to the P2 sun gear, which provides the second stage output to the main shaft. The P2 sun gear, the second stage output, is splined to the main shaft. The P3 sun gear is also splined to the main shaft and rotates with the P2 sun gear to provide one of the 2 third-stage inputs to the P3 pinion gears. The other input is the P3 ring gear that is splined to the P2 carrier. The P3 ring gear rotates around the outside of the P3 carrier at a slower rate than the rotation of the P3 sun gear. This causes the P3 ring gear action to resemble that of a held member. The P3 sun gear then becomes the main path for torque transmitted to the P3 carrier. The P3 carrier provides output torque to the transmission output shaft. Clutches C2 and C4 are applied in 6th range. The C2 clutch locks the turbine shaft and the P2 carrier together, and the C4 stationary clutch prevents the P2 ring gear from rotating. With the P2 ring gear anchored and the P2 carrier providing input, first-stage output torque is produced at the P2 sun gear. P2 output torque is then transmitted to the main shaft. In reverse, C3 and C5 clutches are applied. Applying stationary clutch C3 prevents the P1 ring gear from rotating. Applying stationary clutch C5 prevents the P3 ring gear from rotating. Reverse first-stage gearing is provided by the P1 planetary assembly. The P1 sun gear rotates with the rotating clutch and provides torque input into the first stage. With the P1 ring gear held by stationary clutch C3 and the P1 sun gear providing input, output from the first stage is directed through the P1 carrier. The second stage is the P2 planetary assembly. Input to the second stage is provided by the P2 ring gear that is splined to the P1 carrier. The P2 carrier is splined to the P3 ring gear that is held stationary by the C5 clutch. This prevents the P2 carrier from rotating, causing torque from the P2 planetary gears to be transmitted through the P2 planetary pinion gears. These gears mesh with the P2 sun gear, which is splined to the main shaft, causing the main shaft to rotate in a direction opposite to the rotation of the turbine shaft input. The third stage is the P3 planetary assembly. The P3 sun gear is splined to the main shaft and provides counterclockwise input to the P3 planetary assembly. The P3 ring gear is held stationary by the C5 clutch. Torque is then transmitted from the P3 sun gear to the P3 carrier, which provides output torque to the transmission output shaft. Thank you for watching this video on how an Allison transmission operates and changes gears. For more information on transmission power flows and what differentiates Allison from the rest, contact your local Allison representative.